SMAP stands for the
Sustainable Michigan.
Michigan Endowed
Project.
The Sustainable Michigan Endowed Project. The term sustainability is useful in the same way terms like justice and peace, in that we have sort of an ethical sense that this is important.
Sustainability is about being able to continue.
meeting the needs of today's people without compromising the needs of future generations.
Balancing the interests of today against tomorrow, recognizing that the world is not just about us now.
Our children and our children's children can enjoy the same kinds of amenities that we enjoy today.
The capacity to endure for a long time.
Provide the same sets of resources for the next generation.
Trying to understand what type of quality do we need for the various purposes.
Maintaining the options for the future.
Society is facing countless problems that seem to have no end. These problems often are interlinked, and as we appear to make progress in one, we encounter consequences, sometimes dramatic, in others, forming a tangled web which is not sustainable. Thus, while we have made progress towards sustainability in some issues, a great challenge still awaits us. The goal of the Sustainable Michigan Endowed Project is to bring together the parties involved in these unsustainable systems to find new ways to move away from unsustainable trajectories. Instead, we must consider all aspects of the problem: our planet, the people, and their prosperity.
A good example of the complexity of sustainability is the Brazilian sugarcane industry. They've been able to more and more efficiently produce sugar for humans and ethanol for automobiles. And that kind of efficiency is good in both a prosperity sense and a planet sense. Now, a traditional problem in the sugarcane industry is the fact that you have to burn the plant before you harvest it. Well, that burning creates environmental issues, and so to eliminate those issues, the Brazilian cane industry is moving towards mechanical harvesting. Well, a mechanical harvester is going to throw many untrained, unskilled farm workers out of work. So even with the prosperity benefits of the efficiency, the fact that they're now trying to solve a planet problem means they're creating a new people problem. And that's what makes sustainability so complicated.
The traditional model of science really grew out of studying fairly simple systems. Each change produced a very direct and observable change in the next piece of the system. And one was able to sort of take the system apart and look at it one piece at a time and understand how the whole system worked. But many of the systems we're dealing with now, human systems and ecosystems and the planetary system, don't have those nice properties.
I'm troubled more and more by discussions of things like environmental sustainability, because in some ways it's artificial to take what are really all of the integrated pieces of the larger problem of making things last and looking for endurability in all of our systems that are necessarily related.
Tame problems are what the universities do all the time. They tend to be those problems where the public has a general agreement on what's a desirable outcome, and we know the causes and effects of the problem, so it's easy to let science go to work. Let me give you an example of what I mean. Think back to the polio epidemic of the 40s and 50s in the United States. Everyone agreed this was a terrible problem and it just had to be addressed. But we knew what caused these kind of problems, so we were able to put science to work. And we went from the polio epidemic to scientific research to the development of a polio vaccine. Did not need a lot of engagement of the public. They all agreed this was desirable.
Linear, or normal science, can be applied very effectively to tame problems and follows a common pattern. First, decide on the problem to solve. Then, attain funding for the research. And bring scientists together to perform experiments. Publish the findings to build a knowledge base, which can then be applied to help society, such as in business and engineering, to produce new medicines, consumer electronics, and further advancements in science, such as putting a man on the moon, which is, despite its complexity, a tame problem, because everyone came together with a common goal and worked together to make it happen. However, normal science cannot give us the answers we need for questions on sustainability.
Let's say I want a fresh apple. well, there are very clear standards of what constitutes a fresh apple. But now, if what I say I want is a sustainably produced apple, well, my definition of sustainability and your definition of sustainability may be very different. And it just creates a dramatically different set of issues that have to be resolved.
We're talking about huge complexities, feedback loops, and things that we don't understand yet. We don't really even have theories. And so this complexity lends itself to this idea of wicked problems.
When you try to implement a solution, you expect to have new problems arise. You expect that anything that you do is going to have a reaction. It's going to create either reactions by people or perhaps by the environment.
Recognize that wicked problems don't have single solutions. And the more that we go down a single path, the more that we've decided that we're going to close off 3, 4, or 5 other paths. There's this multiplicity of solutions, and so what we've got to do is we've got to explore all these options.
There are different paths to sustainability in different locations, and because some places have more natural resources than others, and then you have to take advantage of the local conditions.
Without a single solution, it becomes difficult to bring science to sustainability issues. But here's where the university can act as an honest broker. It can bring stakeholders who hold experiences and tacit knowledge together with scientists who hold explicit knowledge, and they can co-create new knowledge. They can decide what the boundaries of the problem are, how to frame the issue, what are potential solutions. To do this well, we have to engage both science and stakeholders. And that's why I sometimes refer to this as engage, experiment, evaluate, and re-engage.
Your questions are derived from what you're hearing outside of the academy. And then we can provide a reciprocal feedback with the community to say, okay, if this doesn't answer the question, then what's the next question that needs to be asked?
Science, academic researchers have information to contribute, and practitioners have information to contribute. But when each of them are working alone, oftentimes we don't really manage to find the most harmonious application of both of these types of knowledge. And so it's really necessary to find some way to pull these domains of knowledge together in a new way.
So trying to strike that balance between sharing what we know and the implications of some of the decisions we make.
Sustainability is an ideology, a way of thinking, a way of life. It's not an end product, it's a vision.
We move towards sustainability, we never really achieve it.
Nobody would be for unsustainable. Nobody. But the devil's in the details. Human values come into play. What people think about the world comes into play. The way that people look at knowledge, how people look at data, and how people interpret data, all comes into the mix of not just whether we think something's sustainable or not, but how far do we have to go to get there.
The tendency is, if it's not broken, don't fix it. One doesn't realize that things are beginning to get broken.
We need to be focusing on the bioeconomy. We need to be focusing more on agriculture, on recreation and tourism, but also on industries that are based on creativity and on quality of life and environmental amenities.
The capacity of our natural environment cannot sustain the trajectory that we're on.
We have to learn to get along. We have to learn to preserve the natural resources that we have.
The natural thing to assume is that there must be trade-offs. Now, the problem with trade-offs is that they're really win-lose situations. So when dealing with wicked problems, we'd really like to achieve a new level of knowledge or a new paradigm of knowledge that allows us to turn trade-offs into complements. In other words, win-win situations.
This needs to be part of the K-12 curriculum.
Design systems that are equitable.
Try and work out those differences.
Allowing scientists to bridge.
Then we're moving towards sustainability.
There has to be a balance with the rest of nature.
The critical question of the 21st century.
You can be sitting there thinking everything's just fine, and yet what you're doing is having an impact on someone else.